Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this session on the instrumentation of infrared spectroscopy. In previous video, we have discussed about how the working of infrared spectrophotometer is carried out. Also, we have seen the four important components. Out of that, we have started with the radiation sources that are used in the IR spectroscopy. We have covered two radiation source, namely incandescent light as well as the nurse blower in previous video. In this video, we will start with the remaining two radiation sources, that is the Glober source as well as the mercury arc lamp. Also, we will cover the monochromator system that is used in the IR spectrophotometer. If you have not watched my previous video, you can watch my previous videos related to the instrumental methods of analysis also. And if you like the content of this my channel, you can subscribe to my YouTube channel. So let's start with our today's session. Before starting, just we will see what are the learning outcomes of this session. After this session, means after watching this video, you will be able to explain the instrumentation of IR spectroscopy. So let's start our today's session. As I said, here we will be discussing the remaining two radiation sources, that is the Glober source and the mercury arc lamp. First, we will discuss the Glober source. Now, Glober source is made up of the sintered silicon carbide rod, usually having a 50 millimeter in length and 5 millimeter in diameter. So this is the typical example of Glober source. So whatever this particular filament that you can see, that filament is made up of silicon carbide rod. It is heated to about 200 degrees Celsius. It provides maximum radiations of about the 5200 centimeter inverse. That is the wave number. The power consumption is normally higher as compared to the nurse blower, but this is also one of the widely used lamp in the IR spectrophotometers. Water cooling is needed to cool the metallic electrodes attached to the rod. It is convenient to use the more expensive and less intense than nurse blower, because nurse blower, as I said, it is having certain disadvantage. It is more expensive, and also Glober source is very convenient to use. Then next lamp that we are going to discuss, or radiation source, that is the mercury arc lamp. Generally, mercury arc lamp is used in the far IR region. There is the wave number less than 200 centimeter inverse. It is a high pressure mercury arc, that is consisting of quartz jacketed tube containing mercury vapor at the pressure greater than 1 atmosphere. So generally, this mercury arc, as name suggests, it is made up of the mercury, and which is jacketed in a mercury vapor containing a quartz jacket. When a current is passed through this particular lamp, mercury is vaporized and excited, and it will be ionized, forming a plasma discharge at high pressure. In the UV and visible regions, this lamp emits atomic mercury emission lines that are very narrow and discrete, but emits an intense continuous light in the far IR region. So these are the various radiation sources that are used in the IR spectrophotometry. Now next important component that is used in the IR spectrophotometer is monochromators. Monochromators is consisting of the series of the different mirrors as well as the different either prisms and the gratings, which are used for the separation of the individual light, polychromatic light into its individual components. The radiation source emits radiations of various frequencies ranging, for example, from 4000 to 400 centimeter inverse. As the sample in the IR spectroscopy absorbs only certain frequency, there is need to use the monochromators, which will allow to pass the only light which is having certain frequencies. So it becomes essential to select desired frequencies from the radiation source and reject the radiations of the other frequencies. That can be done with the help of the monochromators. The selection has been achieved by means of monochromators, which are mainly of two types. You know that one is the prism monochromator and other one is the grating monochromators. Grating monochromators are highly sensitive as compared to the prism monochromators. Now, whatever the instruments nowadays are generally made, they are consisting of the monochromators, that is the made up of the gratings. We will discuss both prism monochromators as well as the grating monochromators in this video. First, we will discuss prism monochromators. These are the favored because of greater range as well as the simplicity. They are cost effective also. Neither glass nor quartz is sufficiently transparent to the infrared radiations. Means glass as well as the quartz absorb the certain amount of infrared radiations, and therefore other materials like halogen salts are used in the manufacturing of the prism monochromators as they are transparent to the infrared radiations. Now this is the typical example of prism monochromator, which shows here diagram. Generally prism is used. This prism is made up of halogen salts like NaCl, KBr, like etc. So white light, that is the polychromatic light, when falls on this particular prism, it will be separated into its individual component and the light is dispersed into its individual wavelength light depending upon the frequency of that particular light. Quarter prisms are only used in the near infrared region, that is the range 0.8 to 3 micrometer. It is absorbed strongly beyond the 4 microns. The most work in the infrared region is done using crystalline sodium chloride as a prism material. It has high dispersion in the range between 5 to 15 micron and it is adequate up to 2.5 micron crystalline potassium bromide, as well as the sometimes cesium bromide is also used, which is satisfactory for far infrared region, that is the region having 15 to 40 microns. In the near infrared region, that is from range 1 to 5 micron, lithium fluoride is used as a prism material. So in the range of 5 to 15, NaCl is used. In the range of 15 to 40, cesium bromide or the potassium bromide is used. Then near infrared region, that is the 1 to 5 micron, lithium bromide is used. All the commonly used prism materials except quartz are water soluble and they are easily scratched. These materials must be protected from moisture either by using desiccants or desiccator or placing in a sealed tube which is evacuated. In the infrared spectrophotometers, the focusing of the radiation is done by using concave mirrors rather than the prisms. These mirrors can be prepared from various materials like metals or glass coated aluminum. As we have seen in the working also, there are two different types of mirrors are used, either flat mirrors or the concave mirrors. Concave mirrors are made up of various materials like metals or glass that are coated on the surface of the aluminum. The main advantage of these materials is that it has no chromatic abrasion and they are also sturdy. Besides concave mirrors, plane reflective mirrors are also used in the prism monochromators. So this is about the working of prism monochromators. Next, we will discuss about the grating monochromators. As I said, grating monochromators are widely used nowadays in the different IR spectrophotometers because of their high sensitivity as compared to the prism monochromators. Gratings means what? Generally, different shapes, that is the triangle shapes, are engraved on the plane surface in a very small range. Gratings are essential, a series of parallel straight lines that are cut out on the plane surface so that if we take a transverse section, it will show as a triangular surface. It is usually constructed from glass or plastic which is coated with the aluminum. Here just I will show you a typical diagram of the grating monochromator. Here you can see this is the plane surface and on this particular plane surface certain lines are engraved which are in the triangular shape. If you take the transverse section, here you can see the triangular shaped surface of that particular grating. So when the light falls on the surface of this particular grating, due to different diffraction angle, the light, that is the white light, it will be separated into its individual component. As you see over here, this grating is continuously rotated and the slit is placed over in front of this particular grating, so that what happens, when this light is separated into its individual component, only the light which is having certain frequency will be passing through this particular slit. So all the individual component is passed through this particular light due to rotation of this particular grating. That's why these gratings are known as the diffraction grating. Grating is generally used in combination with small prism, which acts as a order sorter. Sometimes filters transparent over a limited wavelength range are incorporated with the gratings to increase their sensitivity. They are also used along with the certain filters. Grating monochromators have certain advantages over prism monochromators, as grating construction material is not attacked by the moisture and is not subjected to etching, where on the salts prisms are affected by moisture as well as they can be subjected to the etching. So this is the one of the advantage of grating monochromators over the prism, because they are not attacked by the moisture as well as they are not subjected to the etching. Then grating monochromators can be used over considerable wavelength range. So wide wavelength range can be used can be subjected for the grating monochromators. Grating monochromators are sturdy as well as the long lasting, due to which these are the various advantages of grating monochromators over the prism monochromators. So in this video in detail we have discussed two radiation source. Further, we have also covered the different monochromator systems that are used in the IR spectroscopy. If you have any queries related to the instrumental methods of analysis, then contact me on this particular mail ID, that is the shavishalvi99@gmail.com. And if you like the content of this video, then like my videos, share with your friends and subscribe to my YouTube channel. In next video, we will see the remaining part, that is the sampling, how sample cells are used, and also the detectors that are used in the IR spectroscopy. Thank you.